A very good morning to everyone, dear 9th standard students. This is your sir Sajid from St. Lawrence High School, Ranebennur. Dear children, as you know that in the previous class we have discussed about the potential energy and we have discussed the formula for potential energy, which is nothing but PE is equal to mgh. M is mass, G is gravitation, and H is height. Okay. So since I have covered this chapter, but due to some technical problems, due to the audio has failed, so again I'm just covering it up, so you don't worry about that. Let's try to see very carefully. We start with the example 11.5 in your textbook. So let's try to see this problem, very simple problem. You can see that find the energy processed by the object of mass 10 kg when it is at a height of 6 meters above the ground and given 9.8 meter per second G. Okay, G is gravitation given, which is 9.8. Children, I told you, I hope you remember that in the previous classes also, that is gravitation if not given, so you must consider as a 9.8. If it is given, right, if gravitation is given means maybe in some problems is given as 10, so you must take as 10, but if not given you must take as 9.8 meter per second square. Here it is given, that is 9.8 meter per second square. So first we know that in a physics we write first what is given thing. So given is mass is given 10 kg and height is also given. Height you measure in meters, so height is given 6 meters. So gravitation is also given, which is nothing but a 9.8 meter per second square. So formula we know, that formula which is nothing but PE is equal to mgh. Okay, M is mass, G is gravitation, H is height. So all three things are given here, so we are going to just multiply this and we will keep the answer and we keep the put the unit as a joule. Very simple. Look at here. In this step we can see that 10 kg mass, gravitation sorry, gravitation 9.8 is given and 6 meter is height is given. So if we multiply all that, so it becomes 588 joules. So we are going to multiply this. Here the decimal point is there, so very simple, just multiply simply. So 10 into 98 is 980 into 6, it becomes 5880. Okay, then put the decimal point, so answer comes as 5, sorry, I'll tell you how it is. So answer comes as 5880. If you remove the decimal point, then keep the decimal point after one number. As you can see, the decimal point is after one number, so if you keep the decimal point here, so answer becomes 588.0. You know that point 0 we can neglect, so we can directly write the answer as 588 joules. Joules is the unit, we write as in a capital J. Okay, so next problem we can solve in this way. Look at here, another problem, one more very simple problem is given here. The problem is given as an object of mass 12 kg. Okay, mass is given, children, mass is given. You can see that 12 kg is M is given at a certain height, so height is not given, so height we have to find out. Okay, and object has a potential energy, P is given, PE is given. So what is PE? So PE is given, so here P is given, P is nothing but a 480 joules, it is already given. So we need to find out H. Got it, we need to find out H here. Practice. So what is not given, we have to find out that. So we know that formula, as you can see that formula is kept here. So mgh, so potential energy is given, so we have written 480 joules. So mass is given 12 kg, gravitation we know that 10, because he asked us to take the 10, so we have taken 10. And H is not given, we keep as it is, into H we'll write. So if you suppose we cross multiply that, if we take H outside, so it becomes, if we take H outside, so it becomes H is equal to PE divided by mg. Correct, mg. Got it. The formula becomes like this because we need to find out the H. Got it. So in this way we can see that, you can see here H is taken outside, so H is equal to P divided by mg, so it becomes 480 So it becomes 480 divided by 120. Why 120? Because here you can see that 12 into 10 is equal to 120. So 120 kilograms taken. So 10, here you can see that 10 get cancels here. So 12 ones are 12, 4s are 48. So answer comes as 4. So why meter? Meter is given. So h, height we measure in meters, right? Height we measure in meters, right? So we have written here the answer as 4 meters, right? You can return the answer as 4 meters. Very simple. Okay, fine. So next we try to see. I hope you understand this problem. It's very simple. Next, we are going to discuss some theoretical part of it, and which is nothing but you can say that are the various energy forms are interconvertible. Interconvertible means interchangeable. We can change it, interchange, we can interchange it. Let's try to understand that. Okay, there's an activity, small activity is given. Sit in a small group and discuss the various ways of energy conversion in nature. Discuss following questions in your group. So what are the questions? How do green plants produce food? We know that the plant produce food by photosynthesis. Photosynthesis is a process wherein sun energy is converted into, okay, food. For that they produce, the plants produce the, with the help of sun energy, with the help of water, with the help of nitrogen present in the soil. So all through all that the plant produces the food, okay, and it will grow up. So it does mean that, so here sun's energy is the main energy which is converted, as you can see here. For example, there's a sun, right? Without sun energy which is falls down on the earth, where there are plants, right? There are plants, right? These plants are absorbs this sun's energy and they grow up, okay, like. So here we can say that the sun energy is converted into means nothing but a solar energy is converted into food for the plants, okay. So next, where do they get their energy from? Okay, from mainly from the sun. So why does the air moves from place to place? So here is a very important thing, why does the air moves from place to place? So I'll make you to understand that. Very simple it is. Let's try to see. I'll show you here through the picture. Look at here. For example, there's a sun, right? Here again, there's a sun. Uh, Wait a minute. There's a sun, right? Sun. Got it. It's a sun. Suppose, and then we know that. Sorry. We know that the sun's energy falls to the earth, right? Sun's energy falls to the earth. For this is the surface of the earth, right? Surface of the earth. When the sun's energy falls on the surface of earth, okay, and the air which is present, okay, air which is, for example, with the other color I'll show you, right? Air which is present near the earth, which is get heated by the sun energy, and it slowly rises up, okay, slowly it rises up, creating a vacuum here, isn't it? If this air is rises up, creating the vacuum here, and this vacuum is filled by some other air, some other cool air. Got it? This vacuum is filled by some other cool air. So in this way the air has got movement, the air has got movement, okay. So sun is the main energy to move the air from one place to the other place. I hope you understand this, okay. So look at here, that's the reason. So make look at here, why does the air moves from place to place? Because of the sun's energy. You know that, just now I told you, due to sun energy the air near the earth is get heated and slowly rises up, creating the vacuum there, and that vacuum is filled by some other cool air. In this way the air moves from place to place. How are the fuels such as coal and petroleum formed? So you know that, as I told you in the, I think, last year in the classes, I think your biology sir also told this. Let me tell you once again, how are fuels such as coal and petroleum formed? Coal or petroleum are formed by the millions of years ago. Due to some natural disasters, the living things get embedded in the earth crust, okay, and due to pressure over the long time they converted as a fossil fuels. Fossil fuel means nothing but such as coal and petroleum. Got it? So what kind of energy conversion sustain in the water cycle? Okay, in the water cycle what happens, that also water cycle, let me tell you through the picture. Here suppose there's a sun again. Okay, there's a sun again, and that sun, sorry, sun which is gives the energy. Okay, which gives the energy which is sun which gives the energy which is called as a sun's energy, right? Sun's energy. For example, there's a water down, and that water is get heated through the sun, which is slowly rises up. Okay, rises up through to the water, due to through the water vapors, sorry, through the water vapors, and becomes the clouds. Okay, and becomes the clouds, and that clouds brings the rain, and it forms as a cycle. Okay, it forms a kind of a round cycle. So we call it as water cycle. We call this as water cycle. Got it? This, we have studied this in a 6th, 7th and 8th standard in the biology, I hope. Okay, so here also the sun is the main. Okay, sun is the main reason for the water cycle. Okay, fine. So next, activity. Many of the human activities and the gadgets we use in involves a conversion of energy from one to another. For example, gadgets means the devices that you use in your day-to-day life. For example, there's a mixie at your house. That mixie, it takes the light energy. Okay, means electricity it will take, and electric energy is converted into mechanical energy. There mechanicals means it rotates, mechanical energy. In the light what happens, electrical energy is converted into light energy. In iron box what happens, the light energy is converted into heat energy. In electric kettle what happens, light energy is converted into heat energy. So in touch conversion of energy will be taken place. Okay, remember that. So next, look at here. Let's make a list of such activities and gadgets. Just now I told you, for example, you can say that mixie, you can say that iron box, you can say that water heater, you can say that um, any other appliances like fan. Okay, in this, all this the energy is converted, simply converted to one form to other form, right? So here, identify in each activity or gadget kind of energy conversion takes place. Just now I told you, for example, in the mixie, like electricity is converted into mechanical energy. For in a light, the electricity converted into light energy, right? Electricity is converted into light energy. And some other, for example, in iron box the electricity is converted into heat energy. Okay, in this way interconversion of energy is taken place. Now we can say the law of conservation of energy. Let me tell you very simple, that is, what do you mean by this law of conservation of energy? Kindly write down there. On the law of conservation of energy, which says that energy neither be created nor be destroyed, but one form of energy can be converted into other form. It does mean that, children, so energy neither be created. You cannot create any sort of energy. Let me tell you, the human beings have, we can change it from one state to other state, but we cannot convert it, we cannot initiate it. For example, do you know that who has created the heat energy, who has created the light energy? Okay, who has created the mechanical energy? All these energies are created by the god, isn't it? It is not created by the human beings. So it does mean that energies we cannot create, or we cannot destroy also. We cannot destroy also. How it is, let me tell you very simply. If I tell you, I will give us some time to you, can you destroy all the heat energy from the world? Is it possible to destroy? No. Can it, if I ask you to destroy all the light energy from the world, is it possible? No. Can I ask you to destroy all the mechanical energy from the world? Is it possible? No. So it does mean that energy neither be created nor be destroyed, but one form of energy we can convert into other forms, that we can do. That's the energy conservation law says. isn't it? So energy conservation law says that energy neither be created nor be destroyed, okay, but one form of energy we can convert into another another form. So but we cannot, these are interchangeable, but we cannot initiate the energy, neither we cannot destroy the energy. But remember only a very important thing here, very importantly, try to understand that here we know that, um, let me tell you one important thing. We know potential energy P, okay, potential energy plus kinetic energy. We know the formulas. Potential energy formula is mgh, okay. Kinetic energy formula is half mv square, correct. And this always equal to 0, right? This is always equal to 0 means potential energy, kinetic energy, this point is very important, you remember that, children. Potential energy and the kinetic energy, both if we add together, so we get the answer as 0. 0, what do you mean by 0 here? 0 means here the word 0. 0 means, okay, it means constant, okay, constant means one value, 1, okay, constant means 1. So remember that. Sorry. So remember that, children. So always potential energy plus kinetic energy always becomes a 0, nothing but a constant, as you can see in the picture here. Look at here, you can see in the picture, look at here, marked. So here you can see that, right, here you can see that. So mgh plus half mv square is equal to constant always, right, which is always called as a constant, right, as you can see here, is always constant. So mgh plus half mv square is equal to constant, means potential energy plus kinetic energy is equal to constant, okay. So we find during the free fall of the object a decrease in the potential energy, right, if at any point in the path appears in the equal amount of increase in the kinetic energy. So always it is, you just remember that. So always potential energy, kinetic energy, if you add together, so the final answer we can get it as 0, nothing but a constant, okay. So next, you just go through that. It's very simple, and what is there in that I told you. You just go through once this para. So the next, we can say that rate of doing work. Rate of doing. Last part we are going to discuss rate of doing work. So what do you mean by the rate of doing work? Do all of us work at the same rate? No, of course, isn't it? We cannot work at the same rate, isn't it? For example, there's a running race. See, one can run very fast and another can run very slow, or some can run moderately. So it does mean that all cannot run with the same pace. So all cannot do with the same work. All cannot take the same marks, isn't it? In the examination, it is differs. So rate of doing work, do all of us do at the same rate? No. Do machines consume the transfer of energy at the same rate? No, isn't it? So some machines, for example gadgets like light take less energy, mixie take little more energy, water heater take which is more highest of energy electricity it consumes. So all the appliances means devices also works in a different phase, okay. So agents that transfer energy to do work at a definite rate, let's understand this from the following activity. What the activity we can do with the help of that we can understand. Let's see that. First, what is given, consider two children, say A and B, let us say the weight the same, okay. Both start climbing up a rope separately. Both reach a height of 8 meters. Let you say that A takes 15 seconds, B takes 20 seconds to accomplish a task, okay. For example, two boys A, B, if we ask them to climb a rope, so A can climb a rope 8 meters in 15 seconds, B will climb that same rope 8 meters in 20 seconds. So next, what is the work done by each? The work done is the same. However, a time less taken by the time less taken by the boy A to do the work, right? So who has done more work in the given time? Say it's given time in 1 second. So you know that the boy A has done the more work in 1 second because he has climbed the more. So in this way, according to this, a stronger person may do certain work in the relatively less time. A more powerful vehicle would complete a journey in a shorter time than a less powerful one. Okay, so you can say that. You know that there's a bike and there's a cycle. Okay, or you can compare the bike and car. So which is go faster? Faster. If I ask you, you say that sir, car will go faster than the bike. Yeah. Why? Because it's very heavy, isn't it? So it differs. It is based on their potentialities. Okay, so we talk of the power of machines like motorbikes and motor cars. The speed with which the vehicles change the energy to do work is a basis of their classification, right? So power means the speed of work done, that is how fast or how slow the work is done. Power is defined as the rate of doing work. Remember that power means, I think power is defined with the P, right? Power is defined with the P, letter P, which does mean that rate of power means the speed of the work done. Okay, speed of the power measures the speed of the work done. So power defined as the rate of doing work. Remember that power defined as rate of doing work. Look at here, it is marked here. Let's try to see that. So power is defined as rate of doing work, right? Or the rate of transfer the energy. If an agent does a work W in time t, then the power is given by power is equal to P is equal to W by T. This is very important formula. Children, try to understand that. Okay, this is the formula for the power. So power P refers to the power, W refers for the work, T refers for the time. Okay, so formula is nothing but what is the formula? Formula is nothing but, children, formula is nothing but P is equal to W by T. So wherein P refers to the power, W refers for the work, and T refers for the time. Okay, this is the very important formula as far as examination is concerned, right? The unit of power is watt. Remember that, watt. Watt. You might have observed that. If you don't know, kindly see, kindly check your electricity bill. Okay, every month you get electricity bill for your houses. Kindly ask your parents to show you the electricity bill. So older one. Okay, you just see the electricity bill. In that electricity bill, the watt is mentioned. So what means? Watt means, you know that the in the electricity meter we consider we calculate the electricity through the watt, isn't it? So watts, you might have observed that, suppose a mixie, you take the just invert the mixie and take the bottom of that. In that it is written that how many watts it going to work, right? What's the watt of it? So this is the rating. So power is measured in watt in honor of the scientist Watt. Okay, having the symbol W, which has the symbol W, 1 watt is equal to 1 power of an agent which does work at the rate of 1 joule per second. We can also say that power is 1 W, 1 work, when the rate of consumption of energy is 1 joule. So 1 watt is equal to 1 joule per second. This is very important, remember, for MCQ question. 1 watt is equal to 1 joule per second. 1 watt is equal to 1 joule per second, right? So here it is written 1 watt is equal to 1 joule per second. And then remember that one more thing, what is kilowatt? It's very simple, very simple. For example, 1000 grams is equal to 1 kilogram. You know that. We say that 1 kg. 1000 grams is equal to 1 kilograms. So 1000 watt is equal to 1 kilowatt. Very simple, isn't it? Very simple. So 1000 watt is equal to, this is also very important. Kindly remember this. Okay, look at here. 1000 watt is equal to 1 kilowatt. How 1000 grams is equal to 1 kilogram? We say that 1000 watt is equal to 1 kilowatt. Okay, look at here. 1 kilowatt. How we measure right here? 1 kW. We can write here in this way, 1000 W, or you can say that 1000 joules per second. That's we call it as watt. Okay, the power of an agent may vary with the time. This means the agent may be doing the work at different rates at the different intervals of time. Therefore, the concept of average power is useful. We obtain average power by dividing the total energy consumed by the total time taken. Okay, so total energy consumed divided by total time taken, which is nothing but we can say again, which is, look at here, power. So W divided by T. So W is work done, T refers for the time. I hope you understand it. Let's try to see one simple problem based on that. Two girls of each weight 400 Newton. Okay, 400 Newton. Climb up a rope through a height of 8 meters. We name the girl as A and the other girl B. Girl A takes 20 seconds and girl B takes 50 seconds to accomplish the task. What is the power extended by each girl? Let's try to see that. So power extended by girl A. Let's try to first calculate the girl A power. So girl A, which is she is weighing that is mass into gravity 400 Newton. Okay, our weight means mass into gravity, which is nothing but 400 Newton. Displacement 8 meters, isn't it? Displacement of her is 8 meters. Got it. So you can see here, time taken is 20 seconds. You know that because it is given in the question. Time taken is 20 seconds, and then power P is equal to work done divided by time taken. Work is nothing but W is equal to, in the previous class section we have discussed that W is equal to mgh. Okay, mgs, work is equal to W is equal to mgh. So instead of that we can take mgh. Okay, so we can write mgh divided by T. So 400 mg is 400, isn't it? Mass into gravity. Mg is 400, mass into gravity. Mg is 400, you know that, isn't it? You know that mg is 400. Got it. And then 8 meter height is given in the question, so I have written 8, and time is given 20 seconds, we have written that. Okay, so 400 into 8 is how much? 8 is how much? 400 into 8 is 2400, right? 2400 divided by 20, right? 2400 divided by 20. So 1010 gets cancelled there. So 2 ones are, okay, 2 twos are, and 10 as it is. So 120, isn't it? So here it comes as, sorry, let's try to see where I did wrong here. Let's try to see that. Okay, 400 into 8, isn't it? Sorry, yeah, 8 fours are 32. Okay, sorry, 8 fours are 32. Okay, 20 as it is, right, divided by 20. So here 1010 get cancels. So 2 ones are, 1 remains, 2 6 are, okay, so 6 are, 2 6 are 12, 10 as it is again. So answer comes as 160, correct? So 160 watt. I hope you understand. It's very simple. In that way we can do the next problem also. What is the next problem? Power not next problem, the next girl B. So power expended by girl B is 400 Newton. Displacement is 8 meter. Time taken is 50. Okay, time taken is more. So when you simplify that, you can get answer that is 64 watt. Okay, so work done by girl A is 160 and work done by girl B is 64. So we can say that power extended by the girl is 160 watt, power extended by the girl B is 64 watt. In the same way, we can see the next problem. Next problem. A boy of mass 50 kg runs up a staircase 45 steps in 9 seconds. If the height of each step is 15 meters, find this power and take G is equal to G is equal to how much? A boy of mass 50 kg runs up a staircase 45 steps in 9 seconds. If the height of the each step is 15 centimeters, find the power. Take G is equal to 10, because he has given 10, so we'll take the gravitation 10. So weight of the boy. So weight of the boy is nothing but you know that m into g, mass into gravity, is always called as a weight. So it is given how much? 50 kg. So weight 50 and gravitation is 10 is given. So we can say that 500 Newton, right? You can say that 500 Newton. but I hope you are getting it. Kindly listen to me very carefully. Weight of an object we take. So in order to take the weight, we calculate multiply the mass into gravity. Gravity is 10 given, right? Here you can see that gravity is 10 given. So mass is 50, gravity is 10. So 5 tens are 500, 50 tens are 500. So you can say the 500 Newton is the total mass and the weight of the boy, which is nothing mass into gravity. Okay. So next, the height of the staircase 45 centimeters. Height of the staircase uh, runs up a staircase of 45 steps. So h is equal to 45 into 15 centimeter, which is nothing but a 45 into 15 divided by 100. Okay, so answer comes as 6.75. So time taken to climb is 9. So power, you know that power P is equal to W by T. So power P is nothing but mgh. Mgh, we just calculate the mg is 500, and h is, we know that 6.75 and divided by 9. So when we simplify this, okay, so we can do the 500 into 6675 divided by 9, and after that one decimal point if we keep, the answer comes as 357 answer comes as 3750. So after one putting one decimal point to it, it becomes 375.0. So point 0 we neglect, so we directly write the answer as 375 watts. The unit we write as watt. Okay, got it. I hope you understood this. So next to commercial unit of energy. So this is also very simple. I'll explain you what is the commercial unit of energy, and after that we are going to um, wind up this chapter. And if possible, tomorrow I'm going to send a PDF of lesson work and energy. Kindly write neatly in your notes, and show me on Saturday open day, and kindly correct your notes. And many of the instant students are not still coming up to show the notes, and um, notes on Saturday. So kindly, as soon as possible, get your notes to be get corrected, and if possible you can keep the test on next week. So till then, children, take care. Bye bye.